All right, so we're going to be looking at simplifying and stating restrictions for rational functions. So whenever we're doing irrational functions questions, we always have to consider the restrictions, so when the denominator would be 0. Now, when we did that earlier, we saw that we needed to often factor. And that's, in fact, the first step always when we're doing these simplifying questions. Step 1, factor. So let's take a look at this first one here. So let's factor it. So the top looks factored here. This top looks fine. This looks fine. This here could be factored. And this is similar to the one we saw the other day, where x squared minus 9, we can factor that traditionally, say two numbers that need to add to 0 multiplied to -9, or we can recall that this is difference of squares. But let's get to that. So x minus 1, x plus 3. I'm going to start putting brackets around the tops of my fractions so that everything is nicely paired in these terms. It's a little easier later if we're nicely organized like that. Over, and then here we'll get our factored version, which is x plus 3, x minus 3. Okay, so now step 2 is to state restrictions. State restrictions. So usually we do that off to the side. So we might say restrictions. And our restrictions here are going to be from this bracket here, x can't be -3. This one also, x can't be -3. We don't need to restate it though. And here, x can't be +3. Okay, step 3 is to flip our second fraction. So we're dividing fractions here. So recall, with fractions, you need to flip the second fraction and change the multiplication. So flip second fraction if we have division. So let's do that for a sec. So here we're going to get x minus 1 over x plus 3. Nothing changes with that fraction. But we flip our second, change it to multiplication. We're going to get x plus 3, x minus 3, all divided by x plus 1. Now, you may notice we have a different thing on the bottom. So this fourth step is to check for more restrictions. Check for new restrictions. Check for new restrictions. So we have a new one here, that x can't be -1. Okay. Now we want to try to simplify this. So in order to simplify a rational function, we want to find things that are the same on the top and the bottom, but it's very important that everything has to be factored, everything has to be multiplying. So right now, everything on the top is multiplying, everything on the bottom is multiplying, so I can cancel entire terms. I can't just cancel like a little piece from inside. I can't like say cancel this x and this x. I can only cancel entire things in brackets. So the only common one top and bottom is x plus 3. So we'll cross that one out and that one out. And x minus 1, x plus 1, those aren't the same. X minus 3, none of those are the same. So that's it for simplifying. So we get x minus 1 times x minus 3 over x plus 1. Okay, now you may be tempted to FOIL or expand the top here. We don't want to do that. Simplified form is always factored form. All right. So that was step 5, actually, simplify. So let's write that down just so we have a full list here. Simplify. Okay, so one thing to note is if we look at our restrictions from the beginning and from throughout our process and our final equation, they don't look like they match, right? So we had a restriction of -3. There's nothing indicating that here, or +3. Well, there's one on the top, but that shouldn't matter. -1, well, that's still there. Okay, and that's actually one of the reasons we need to state the restrictions early, is because they are restrictions on the equation, but when we rearranged it, some of them kind of disappear or become hidden. And it's very important to have these restrictions remaining stated because some of them are not obvious, or some of them, in a way, aren't there anymore here, but they are in the original equation, and that's really what, when we did some of our simplification steps, say flipping the fraction or canceling things out, if we didn't state the restrictions ahead of time, then that information would be lost. So that's why we need to do it. So a final answer has a full list of restrictions and a simplified rational function. Okay, let's try another one here. So once again, our first step is to factor. So let's start factoring. I think that left fraction looks fine. 2x. Let me put brackets around that. Okay, the top here, can we factor that? Oh, well, I think we can common factor it. So let's try 3x plus 2. 3 is common to both terms. Here we need two numbers that add to 4 multiply to 3. This would be, say, +3 and +1. And now we want to write our restrictions. Now that everything's factored, restrictions. So x cannot be, and let's start at the left here. So from this term, x can't be 0. From this bracket, x can't be -3. From this bracket, x can't be -1. Okay, so next we want to flip the fraction if it's division. This is not division, so we don't need to do that. So now we can start simplifying. We also, because we didn't flip a fraction, we don't end up with any additional restrictions, but you can always just double check. And now we want to simplify. So let's see. Well, we got x plus 1 on the top and bottom, so we can cancel those out. What about the rest? I don't really see any other ones, so I think that's all. So we'll just write out these multiplications. 3x plus 2 over 2x plus 3. And that's fully simplified now. Everything's common factored or factored. Our restrictions are all stated. All right, let's try one more here. And this time it looks like we have some division and we got a lot of factoring to do. So let's start by factoring everything. So x minus 3 over x plus 2. Division here. Two numbers that add to -7. Multiply to 12. I think it's going to be -3. -4. Here we want to add 3, multiply to 2, so that'd be 1 and 2. So x plus 1, x plus 2. Put brackets around these just to keep them nice and organized and everything look consistent. Let's state our restrictions. Okay, so we got -2, -1, and -2 again. So we don't need to state it twice. So -2 and -1. Okay, so now let's change it to multiplication by flipping the second fraction. times x plus 1, x plus 2, x minus 3, x minus 4 on the bottom. Okay, so should see if there's any new restrictions, and there certainly is. 3 and 4 are new restrictions. 3, 4. So now we have a full list of restrictions. Now we can try to simplify. Remember, you always want to state the restrictions before you cancel things out and simplify. Okay, so I have x minus 3 on top and bottom here. Let's cancel those out. And anything else? Looks like we got x plus 2, x plus 2. And lastly, we'll just state what's left. So x plus 1 over x minus 4. And that is simplifying rational functions, stating restrictions when we have division and multiplication.